Hi students, welcome to today's class. Today also I am explaining differential equations. Yesterday I explained about the formation of differential equation by taking one example. Okay. Now today's class also I am taking the same topic, that is formation of how a differential equation forms. What is the need of finding the differential equation? Okay na? So let us check by taking a small example. Consider an equation x square plus y square is equal to a square. X square plus y square is equal to a square, where a is an arbitrary constant. I am saying a is a real number. By seeing this equation, then immediately what you will think? What is the equation represents? The equation is a circle. It is a circle with the center 0, 0 and radius is equal to a. Here a I am saying a real number. That means real numbers means, of course, it is a positive real number. Why? Because it is a radius. Okay, right. That means it represents a family of circles. I am saying one word, that is family of circles. That means what? Depending upon a value, you are getting one circle. For example, if a is equal to 1, you will take one circle, another circle, another circle, another circle, like that. Depending upon your a value, for all the circles are center is same. That is, they are all concentric circles with a different radii. A will change as if you take a value, you will get a new circle. If you take a is equal to 5, you will get 5 square 25, you will get a circle with radius 5. Okay, now, so you will get a family of circles. Now, my intention is, so for example, this is x square plus y square is equal to 1. This is x square plus y square is equal to 2. This is x square plus y square is equal to 3. This is x square plus y square is equal to 4. So on, you will get a infinite number of circles you will get. Now, my aim is you have to find out an equation which satisfies all these equations 1, 2, 3, 4, so on infinity. You have to find out an equation in which that equation should satisfy each and every equation of the family of the given circle equation. That means what? You have to eliminate a value. You have to eliminate a value. Why? Here a takes so many values. A belongs to set of real numbers. So if you are able to eliminate a, then it is then you will get an equation which satisfies all these equations. All these equations. Now you have to get an equation. Our aim is to eliminate this constant a. Then how to eliminate that constant is the one and only one process, differentiating the given equation with respect to x on both sides. Okay now, right. Now if you differentiate it with respect to x on both sides, what you will get? 2x. This is y square 2y, that is a dy by dx, a square derivative is 0. That means x plus y into dy by dx is equal to 0. Understand this? So this is the equation which satisfies each and every member of the family of the circles x square plus y square is equal to a square. How, sir? Let us show with a proof, right? Let us take the first equation, x square plus y square is equal to 1. Now you differentiate, what happens? X square derivative 2x, y square derivative 2y, y derivative dy by dx is equal to 1 derivative 0. Again you are getting x plus y plus dy by dx. Whose equation is this? Are you getting or not? Otherwise, you take another member, that is x square plus y square is equal to 4. Now, do you differentiate x square derivative 2x, y square derivative 2y, again dy by dx, 4 derivative 0, again you are getting x plus y plus dy by dx is equal to 0. Again you are getting, is it not this equation x plus y into dy by dx is satisfying each and every member of the family of the circles given by the equation x square plus y square is equal to a square? Understand or not? Okay. So, that means our main aim is we have to get another equation. That means already this equation is there, but we do not know the value of a y, because here a is a we are taking a variable, it takes a infinite number set of values you are taking. That is why you have to select another equation in which the equation should satisfy, the equation should be the solution of each and every member of the family of that circles. Okay. Now, from this we will say that here here there is a one and only one constant. So, sorry, only one constant is there. Here constant means here for each and everything you will get different values. Then it is needed here, since here only one a value is there. So, you are only one constant, therefore, x plus y dy by dx you are differentiating with respect to x only one time. So, here constant, number of constant dy by dx is equal to 1. Okay, now, right. Let me explain the same concept using another example. Dear students, let me explain this formation of differential equation by taking another example. Let us take an equation of the form x square by a square plus y square by b square is equal to 1. Here a and b are two arbitrary constants. That means here we know that x square by a square plus y square by b square this equation represent an ellipse, either a greater than b or a less than b, whatever may be that ellipse, with center is equal to 0, 0. Let us say that for our understanding a is greater than b. So, your major axis is 2a and the minor axis is 2b. So, everything we learned in our conic section. That means, depending upon a value, you are getting a family of ellipses. Different ellipses you will get. So, how many ellipses you will get? A and B are set of real numbers. Of course, A is the length of semi-minor axis, B is the length of semi-major axis. Okay, now, so you are getting infinite number of infinite number of ellipses you are getting. Now, you have to find out an equation which satisfies all the equations of the family of this ellipses. For example, this is a x square by 4, this is y square by 2 is equal to 1. That is a one of the member of this family of ellipse. So, this is equal to x square by 6 plus y square by 5 is equal to 1. This is x square by 7 plus y square by some 5 is equal to 1. This is also one of the member of this family of ellipses. Now, you have to find out an equation which satisfies all these equations. Understand this? To do this, now what you have to do? You have to eliminate these arbitrary constants a and b. Okay. How is it possible? It is possible only with the help of differentiation. Okay, now let us differentiate this given equation. So, remember that here you have two arbitrary constants, a and b are two arbitrary constants. So, here 4 is a constant, 2 is a constant, 6 is a constant, 5 is a constant. There are two arbitrary constants. Let us eliminate a and b by differentiation. Okay, now first differentiate this equation with respect to x on both sides. So, now what you will get here? 2x by a square plus 2y by b square into dy by dx is equal to 0. Okay, now. So, y square derivative 2y, again y derivative dy by dx. There is still we can simplify this equation. 2 we can cancel. So, this is equal to x by a square y upon b square into dy by dx is equal to 0. Again, we will differentiate this equation with respect to x on both sides. Let us see what is the derivative of x by a square. This is 1 by a square plus 1 by b square. You put it outside. This is y into dy by dx, u into v formula. So, you call it as this is first equation. This is y into d square y by dx square plus dy by dx into again dy by dx, you can whole square you will do. So, that is you call it as equation number 2. From these two equations, from 1 and 2, if you take this, how can we eliminate? Is it possible to eliminate from using these two equations? Yes, it is possible. No need to do further differentiation. Using this 1 and 2 only, you can eliminate these equations. How can we eliminate? So, very easy one. So, from this, you can take this like that. So, you find out the a square b square value here. So, this is equal to y by b square into dy by dx is equal to, this is minus x by a square. So, this is equal to a square by, otherwise you can do like this. So, your this is equal to, take minus x this side. So, this is a minus y by x into dy by dx is equal to. So, I am taking minus x this side, minus also is equal to. So, this is equal to b square by a square. You call it as third equation. So, your b square by a square value is equal to how much? Minus y by x into dy by dx. So, here what I am going to do is, you multiply with b square on either side. You multiply with b square on either side. So, you can multiply, no problem. Why? Because b cannot be equal to 0. So, you multiply, what happens? This is a b square by a square plus y into d square y by dx square plus dy by dx whole square is equal to 0. Okay. Now, and in that place of b square by a square, can I substitute minus y by x? So, this is minus y by x into dy by dx plus y into d square y by dx square plus dy by dx whole square is equal to 0. Understand? Now, I will write it in an order. So, we can write down this as a y into this is equal to f, otherwise y2 of x. This is a y2 of x plus, so here this is a dy by dx, that is equal to y1 square minus y by x into y1 is equal to 0. Here you know that, so y2 we can call it as y2. You know that what is y1? y1 means first derivative, y2 is second derivative. So, this is the equation in which satisfies each and every member of the given differential equation. Okay, now we can check it. We can check it by taking x square by some a square plus y square by b square is equal to 1. You can substitute here, you can check it. So, otherwise you can multiply with the x also. Therefore, xy into d square y by dx square plus x into dy by dx whole square minus y into dy by dx is equal to 0. This is the equation in which you are not getting any arbitrary constants a and b, so that this equation definitely satisfies each and every member of this equation. If you observe here, what is the order of this equation? Order of that equation is 2. So, here how many constants are there? 2 constants are there. Now, here I am going to use one word, a very important word, that is effective constants. I am using one word, that word is effective constants. What is meant by effective constants? What is meant by effective constants? See here, a and b are 2 arbitrary constants. That is why you need to differentiate the given function 2 times. In the previous example, that is x square plus y square is equal to a square. There you have only one arbitrary constant. So, you are need to differentiate with respect to. Now, I am going to give an example what is meant by effective constants. Generally, students will have a false information that they will count the number of constants a 1, 2, 3, 4. If their number of constants are 5, therefore order of the differential equation is 5, they will write it as. But I am using one word what is meant by effective constant. So, let me explain using one example. Consider an equation y is equal to k times e power x plus L times e power y plus 1 by m times e power x plus 3 by n times e power y. Now, what is the order of the differential equation belongs to this family of some curves? Generally, students, what I told in the previous examples by taking, in the given equations, if there are n number of arbitrary constants are there, therefore order of the corresponding differential equation is also n, I am saying. But I am using one word, effective arbitrary constants. What is meant by effective arbitrary constant means, let us see here. If anybody see that here how many constants are there, if you count the number of constants here k, L, 1 by m, 3 by n. Of course, I forgot to write down k, L, m, n. K, L belongs to set of real numbers. I forgot to write set of real numbers. Here 1, 2, 3, 4, 4 constants are there. Therefore, order of the corresponding differential equation is 4. Generally, if we conclude that, so our conclusion is wrong. Why? Because we have to, even though they appears to be 4 constants, we can simplify this equation and we can extract the effective constant. What is meant by that? So, let us see the first and last one and the second one, first and third one, second one and third one. So, y is equal to here e power x, we can take e power x constant outside, common outside, 1 by m e power x plus, here also e power y is there, e power is there. So, we can take e power y common outside, L plus 3 by n e power y. So, now y is equal to, then k is a constant, m is an arbitrary constant, sum of these two constants is also a constant. Therefore, k1 into e power x, where k1 is equal to k plus 1 by m, L plus 3 by n, L is a constant, n is also a constant. You can write it as k into e power y. So, this is your required equation. So, this is called effective constants, effective arbitrary constants. Understand this here. So, here how many, then further can you simplify anything? Can you simplify anything this? Nothing you cannot say, but here you can simplify. But here how many constants are appears to be? There are 2 constants only, k1 and k2. Therefore, order of this differential equation is equal to 2. That means you need to differentiate this equation 2 times to eliminate these constants and k1 and k2. Understand this? So, but don't have the simply one misconception that by simply counting the number of constants, therefore, order of the differential equation is that. Don't have that misconception. First, you simplify the given given equation if possible. If it is not possible, okay, we cannot do anything. If possible, you simplify this. Understand this. Then sum or product of any 2 constant can be written as another constant. So, this k1 and k2 are called real constants, real arbitrary constant, they are called effective constants. That is why the order of this differential equation is 2 only. Therefore, you need to differentiate only 2 times, not 4 times. Okay, now I hope that you understand this concept. Welcome to this problem. So, in the previous examples, I have given one differential equation. For that, we have find out the differential equation. Now, here, so in some problems, there won't be any direct equations won't be given. So, you have to frame the equation and then differential equation. Then see here, first to frame the equation here. So, what is the given data? Form the differential equation of all circles, touching the x-axis. Okay. So, it is touching x-axis, x-axis and y-axis, touching the x-axis and the center on y-axis, That means, for example, this is a circle, First it is touching y-axis and center is on y-axis. So this is a one circle, this is another circle, this is another circle, of course, like that. So how many circles you will get? You will get a infinite number of circles. First of all, you have to find out the equation of the an equation which generalizes the all the circles. Okay, you have to find out a general equation in which if you substitute different values, you will get the family of circles. Okay, so let us say that the center will be, the center is some a comma 0. Why? Because he is saying that the center lies on y-axis, that a may be positive, may be negative. So if it is if the circles are above the x-axis, a is positive. If the circles are below the x-axis, a is negative. So when it is a comma 0, so this will be a, therefore radius is also how much? A. If it is a comma 0 means this length is also a, therefore radius is equal to a. A is an arbitrary constant. Try to understand. Now what is the equation of the x minus h whole square plus y minus k whole square is equal to r square? We have a formula whose center is h comma k, radius is r. So this is x minus a whole square plus y minus 0 whole square is equal to a square. Understand? Now simplify, this is x square plus y square. So this is minus 2ax. Here a square will get cancelled. So this is equal to 0. Understand this? X square minus 2ax plus a square will get cancelled. Y minus 0 is equal to y, that is equal to y square. So this is the equation of family of circles which touches the x-axis and whose center lies on the y-axis. Understand this? Here a is an arbitrary constant. That means given a value is, if you give a value is equal to 1, a is equal to 2, a is equal to root 3, a is equal to root 4, you will get a family of circles. Now you have to, what you have to do? So you have to find out a differential equation which satisfies each and every member of this differential equation. Each and every member of this family of circles. Okay, now, so here how many effective constants are there? There is one and only one effective constant. That's why how to remove that a value. Okay, now, so how to remove this a value means the one and only one method is differentiating this equation with respect to x one time. So this is equal to 2x plus this is a 2y into dy by dx minus 2ax derivative is equal to how much? 2a is equal to 0. 2 you can cancel. So therefore your a value is equal to x plus y into dy by dx. Understand? Your a value is x plus y. So now substitute here a value. So this is equal to x square plus y square minus 2x into what is our a value? X plus y into dy by dx is equal to 0. Understand? Now you can simplify this. So this is equal to x square minus 2x square. This is minus x square plus y square minus 2xy into dy by dx is equal to 0. You can write it in a simplified form. Therefore, x square minus y square plus 2xy into dy by dx is equal to 0. So this is the required differential equation which satisfies each and every member of the family of circles represented by the equation x square plus y square minus 2ax is equal to 0. Understand this? Now, what we are going to see is the reverse process we are going to see. Now, what we are going to explain is, so this type of different number of problems are there. Just to go through what are the materials you have while you are preparing. So this is one of the examples I am taking. Here only one constant, we got only one constant. There are some problems, there you will get 2 or more constants also you will get. Effective constants. Okay, right. Now our thinking is how to think in a reverse process. That means given a differential equation. So if it is a given a differential equation, we have to find out an equation, otherwise which represents a family of curves. Given a differential equation, reverse process, given a differential equation, we have to find out an equation which represents a family of curves, that is a reverse process. Given an equation, you can find out the differential equation. Anybody can do. That is not at all a difficult task. If you have one constant, differentiate with respect to x in one time, that constant will be removed. If you have two effective constants, differentiate that equation, family of the curves, two times, you will get a differential equation. There is a one and only one procedure. Simply going on differentiating. Okay now. So you have a good number of problems here. Now our discussion is, given a differential equation, how to find out the equation of the curves which represents a family of the curves. Okay now. So for that we have various methods we have. So such a type of methods are there. So let me explain one by one. Welcome back. So I am going to explain variable and separable method. Okay now. Now once again I am reminding you. So we are doing a difference process, reverse process. What is the reverse process means? Given a equation of family of curves, you can find out the corresponding differential equation. Now our point of discussion is, given a differential equation, how to find out the equation of the family of curves. Reverse process I am doing. Understand? This process is called, what you call this process. That means given a differential equation, finding an equation of the family of curves. Those family of curves may be circles, may be ellipse, may be parabola, may be anything, pair of straight lines, whatever may be that. Understand? One differential equation will be given, you have to find out the family of curves. Okay. This process is called solving differential equation. Solving the differential equation. Simply they call it as solve the differential equation. Solve the differential equation means what? You have to find out the equation of the family of curves. Okay. So if the equation of the family of curves is given, finding the differential equation is somewhat easy method. There is one and only one method. But if the given differential equation, if you want to find out the equation of the family of curves, there are different methods are there. So one of the method is variable and separable method or type. Let me explain this somewhat detailedly. Let us say that one differential equation is, so dy by dx is equal to f of x into f of y. So here f of x is equal to, it is a function of the variables x. F of y is a function in the variables y. Now what I am going to do is, can I write this as 1 by f of y into dy is equal to f of x into dx. This step, what I am wrote, this is called separating the variables. This what you did is separating the variables. That means if it is a dy is there, here a function of y should be there. Here if it is a dx is there, here what should be there? A function of x should be there. That is called separating the variables. Understand? First we will do that. We have to separate all x one side, all y's one side, all boys one side, all girls one side. Like that, to separate that. Now let us take integrating on both sides. 1 by f of y dy is equal to 1 by f of x dx. Understand? F of y. 1 by f of y dy is equal to integral 1 by f of x dx. Let us say that, so here one thing should be here, what you have to know. So, f of y should not be equal to 0. So, you should be careful while whichever we are taking in the denominator, that function cannot be equal to 0 for any value of y. Understand? That should be keep it in mind. Otherwise everybody knows that. Okay, right. Now, let us say that there is a function whose derivative is equal to 1 by f of y. There is a function g of y such that g dash of y is equal to 1 by f of y, and another function is also there, f dash of x is equal to f of x. That means the derivative of that function is equal to f of x. There is a function f of x is equal to derivative of that function is equal to f of x. Now, so that means if you take the derivative on both sides, so if you take the differentiating with on both sides, so 1 by f of y is equal to, so this is, let us take a function. So, consider here g dash of f is equal to, g dash of y is equal to 1 by y. There is a function f of x whose derivative is f of x. There is a function g of y whose derivative is 1 by f of y. Therefore, we can write down, so if you take integrating on both sides, so if you integrate on both sides, what happens? If you integrate on both sides, what will happen? So, therefore, g of y is equal to integral of 1 by y is equal to, you can write down g of y. So, therefore, your solution is g of y is equal to capital G of y is equal to capital F of x plus c, where c is a constant of integration, you can write down. Okay, now. So, I hope that you understand this solution. So, let me take a small example and explain this concept detailedly. Welcome to this problem. So, here solve the differential equation. There is a differential equation is given, x into y into dy by dx is equal to 1 plus y square upon 1 plus x square into 1 plus x square. So, once again always remember theoretically that, so the given as solving the differential equation means what? Reverse process. You have to find out the equation of family of curves. You have to find out the equation of family of curves whose solution is this. Understand this? Right. Then how to proceed this plan? So, using variables and separable method. So, take all y terms one side, all x terms one side. So, here I will take 1 plus y square this side. So, that is equal to y by 1 plus y square dy is equal to there 1 plus x square upon x into 1 plus x square into dx. This is called separating the variables. Here all y sides, all x sides. So, remember that. So, if it is a dy is there, it should be a function of y. If it, that means f of x into dx is equal to f of y into dy. So, this is a remembering the variable and separable method. So, now the first thing is I separated. Now, let us take the integrating on both sides. Let me see here 1 plus y square derivative is 2y. That is why, so this is a 2y by 1 plus y square dy. So, you call it as 1 by 2, put 2 here. So, here if you separate here, so this is a 1 plus x square plus x by x into 1 plus x square dx. Now, if you separate this here 1 plus x square will get cancelled, that is 1 by x plus, if you separate x will get cancelled, 1 plus x square dx you will get. Okay, now you differentiate, integrate on both sides. So, this is equal to 1 by 2 into, what is this? 2y by 1 plus y square means what? Log of 1 plus y square to the base e. So, this is equal to log of x to the base e. This is 1 by 1 plus x square means tan inverse of x plus constant of integration. You have to compulsory, you have to write down the constant of integration. Okay, now. So, that is log c to the base e. For that only, so in the family of circles, definitely there should be a constant. So, constant of variable you have to variable of constant you have to do, that is this only. Understand this? Right. then almost the problem is over. Then how to simplify this? Then you take all the log terms to one side. So, this is equal to take this side. So, this is equal to log of 1 plus y square under square root. This is equal to, if you take this is log of cx to the base is equal to tan inverse of x. Understand this. By log a plus log b is equal to log a b, take this side. So, again this is log a minus log b. So, log a by b, that is a log of root of 1 plus y square upon cx to the base c is equal to tan inverse of x. So, this is equal to root of 1 plus y square. Root of 1 plus y square by cx is equal to e to the power of tan inverse of x. Okay, now again, so this is equal to final answer root of 1 plus y square is equal to cx into e to the power of tan inverse of x. This means almost this will be your final answer. That means this is the equation of the family of curves whose differential equation is this. Understand this? I hope that you understand this concept very well. Y by 1 plus y square, 1 plus y square derivative is 2y. That is why 1 by 2 log of 1 plus y square. So, this is log x, that is tan inverse of x. We have taken all to one side and we wrote like that. Okay, now, right. I hope that you enjoyed today's class with some more problems and some more class concepts. The tomorrow's class also I will stand before you. Until then, all the best.